Hello, everyone, and welcome to those who are tuning in, whether it's morning, afternoon, or evening in your part of the world. I'm Nadia, and I'm thrilled to be your host for the Microsoft Reactor live stream this evening. But before we dive into the main event, I'd like to remind everyone about the Reactor Code of Conduct. Our aim is to cultivate a positive and inclusive environment for all participants, so let's keep our interactions respectful and supportive. Today, we are joined by MJ, who is the Technical Director of Playtime Solutions and a Microsoft Azure MVP. MJ will be taking us through his second session of the Let's Talk Vector series, which is deploying Qdrant on Azure. And if you've missed out on the last session, I will pop that in the chat for you. Throughout this session, feel free to drop any questions in the chat box and we'll do our best to address as many as possible. We'll also be sharing additional resources and links in the chat and including information on how you can become a Microsoft MVP. For those who want to revisit today's session, you can catch a recording later on our Reactor YouTube channel. So without further ado, let's give a warm and virtual round of applause to our amazing speaker. Take it away, MJ.
Hello. Hi, Nadia. Hi, everyone. Nice to be back. And it's my second installment of the year-long series about Let's Talk Vectors. And this time around, I'll be talking about something non Azure specific, but still works with Azure. So if you know what I mean, like it's that a bit trick over there. So for today, I'll be talking about Qdrant, okay, on Azure. But here's a full agenda for the next time that we'll be in touch with each other. So first off, we'll be have a quick recap of what we talked about in the past. What is Qdrant? Why do we need a vector native database? And what are the hosting options out there if you're gonna use Qdrant, right? And I'm gonna show those different options through a demo. So first up, just reintroducing myself again. So I'm MJ, Microsoft MVP. Been through the whole circle of Microsoft here and there, but never inside Microsoft. So that's why I have a very interesting background, being as part of these different technology trends within the Microsoft space. And where we are at the moment is the whole data Gen AI race. But in particular, I've been fascinated about vector database because as I look back in my career, majority of the things I do, or like the hard things that I do, are moving data across. And then this time around, the next iteration of that challenge is about using this different type of data, which is vectors, right? I talked about that in the previous episode, but for today, I'll be talking about, you know, um, Quadrant. Just to recap, in Azure, there is no native vector database out there at the moment, right? So there's nothing like Azure Vector DB, or like Azure, IVD or something like that. That doesn't exist at the moment, right? However, the options out there are, if you're native in Azure, is if you're gonna go through a search approach, you might be looking at something like Azure AI Search, and your AI search capability becomes your vector storage. Hence, that becomes your vector database. And if you want to go through a NoSQL route, you can use Cosmos DB or Redis on Azure. And if you want to go through SQL, or um, you can use something like Azure SQL or Postgres, Flex Server. But again, the landscape is kind of big at the moment, and there are a bunch of different offerings here and there that we are experiencing that Kubernetes era of vector databases. We're in like which one would be the winner, and we'll hope to find out by the end of the year or maybe next year, right? In particular, if you look at pure vector DBs out there, you have things like Chroma, Milvus, and Qdrant and Pinecone, right? So Qdrant is a pure vector database. So why Qdrant, or what's up with Qdrant at the moment, right? So two things that as kind of like someone who is looking at these technologies, right? It's always um, important to look the longer term horizon of where this is going, and like where should you invest your effort and like technology learnings here and there, right? Um, well, Quadrant is a startup that recently raised 28 mil to basically kind of like scale their operations. So meaning they've actually identified good opportunities and good problem statements out there that Quadrant can actually be the good fit for those problems, right? And second is that it was when XAI, this company XAI, which is the whole part of the ecosystem of Twitter, Tesla, and that kind of circle. They've It was found out that they've actually been they forked Quadrant, and turns out they've been using Quadrant for their one of their features in Twitter or X. So there you go, right? Like there's already a big player using Quadrant at the moment. But what is Quadrant, right? Like it's to easily explain what Quadrant is that first it's open source. And the thing about Quadrant that makes it a bit different is that it's not just a vector search. They position themselves really as a database, right? But depends on how you interact with them here and there. Like they might actually point out that maybe database is not the right term for it, right? Like Quadrant is a vector technology, right? That's just how they frame it, and they support a bunch of client SDKs and dashboarding capabilities as well. It's scalable because they support this HNSW, which something that allows you to perform this complex vector search or operations on a massive scale, like billions of records of vectors. You can kind of like still find the nearest neighbor, right? Remember last time I was talking about like what vector databases are, and it's about finding the nearest neighbor in that whole vector space. So it supports HNSW. So I think if you're looking at a vector DB or a vector technology, I think the first thing you might need to look at is if it supports HNSW. So for other technologies out there, they don't support this one yet. So that means it's going to be a bit challenging to perform really big queries or like really massive queries on billions of records. Um, Quadrant also supports various distance metrics, things like cosine similarities and things like that, that AI search also supports. So it's not lacking those set of features that you might look at things like AI search or other managed platforms out there. And the last thing is that or second to the last thing is that it supports it's a top performing in terms of like various benchmarks out there, right? You can actually just search it in the web, and like Quadrant is really kind of like one of the leaders in terms of like those different tests. But most of the tests out there are around just how efficient like query is. Like it's just how fast can you find similarities and things like that, right? And lastly, it's written in Rust, so they had the opportunity to actually start from the ground up, and like write in a modern language of choice, which is something like Rust. So here's the high level overview or the architecture of Quadrant, right? Um, if you look here on the left, by the way, it's very fascinatedly illustrated here by the team. So if you look at the left, here the programmers or developers who are probably they have an application, like let's say web application, mobile applications, and most likely they're probably interacting with something like web API or a backend, right? Or maybe it's an internal system, internal network. They're um, like they are probably like interacting somehow. And the thing is, those backend interactions require a database, right, or a data store of some sort, and that's where Quadrant comes in. Wherein like you can just interface with a lot of different backend clients, or maybe even front end, um, and then from there you interact with the concept of a collection, right? Um, so within a vector DB like Quadrant, a collection is something like a table. If you look at in the SQL world, like collection is a form of like a table, right? In Cosmos DB, depends on which Cosmos DB technology you use. They also use the concept of collections. Yeah, so basically the collection is the one that holds the list of entities, right? The reason why it's not called a table, or probably not called a table, is that because these collections can vary in different formats. So it's not really like a SQL relational type of like table, right? So they can hold different values as well. Um, and then from there, like, you set the Euclidean distance, which is like, again, the point um, in time space of that record in that collection, right? And then from here, right, this is where the indexing capability comes in, right? So if you look at back then at AI search has a concept of an index and an indexer. So the index holds like, the shortcut towards the value that you're looking for. So in this case, it's kind of like implementing that same capability. And then, um, the metadata in AI search is called something like a payload here in in Qdrant, right? So think of it this way, right? Like on the left side portion, this is where you store the data. This is your indexer, and then this is your kind of like metadata of some sort. So that just means that all of these are all stored relatively in one storage, right? So what this means is that as a developer, you might be interacting with Qdrant to store data, right? Or maybe you probably want to do search as well, right? Hence, like there must be a an arrow back towards the developers, right? However, what's important here is that ML engineers, or the um, machine learning engineers who have data of some sort, right? They probably don't want to interact with the backend application directly, right? Nor you don't want them to interact with a transactional database of some sort, right? You probably want to just compare data on a vector to vector level. So that means that, application developers can keep on, populating the data on this vector data storage. And then the ML engineers, when they perform their kind of like magic queries or magic inferencing of some sort, they can actually use, deep learning models and compare the vectors themselves, right? Without having to go to the loop of that interaction. So that's just one approach of this, right? Like, so that just means that, ML engineers can create inference backends wherein like, oh, if someone search for a cat, and like, that image could become a husky or a cat and a hair crew. And like, how relevant is that search query for you, right? Yeah. Before I move on to the next slide, there are like a bunch of questions in here. I'll just quickly um, look at them and see if I can answer some of them. All right. So Harry, yep. Speaker video. Okay, thanks for hosting by Cigar. Harry asked, what are the advantages of writing this product using Rust? Um, so I would say the advantage of using Rust at the moment is that when you're designing like things like databases, or things like this, it requires a lower level type of like interaction. So they're very heavy on memory management and like IO, input output, and things like that, right? So it's not like creating a web application. And Rust is a modern language that kind of like supports a very effective way of creating these systems, right? In a way that's very developer friendly. Um, Rust is a very loved language at the moment by the systems engineer, right? And yeah, like you basically get the advantages of having to use of the things like C and C++ of the past, but with the modern flavor, right? Um, then Sagar said vector database and vector search are must for building RAG-based applications. Yes, actually you're right, right? So vector databases are actually a must at the moment, because for RAG-based application, instead of like creating a giant model out there, right? Like let's say you want to fork GPT-2 or GPT-3 or something like that, then you want to build your data on top of it. That's a very expensive exercise and probably not the best use case for all the time, right? So in RAG-based application, what happens is that you actually just use vector embeddings, like this vectors in here, and then this vectors is something you can correlate to a large language model such as OpenAI, right? And then you use the embedding models of OpenAI, such as ADA 002, so that they can actually talk to each other. So that means that your data is stored in something like Qdrant, and then the open data is stored in something like Azure OpenAI, and then through vectors and through embeddings, they can actually talk to each other. So when you ask a question to that RAG-based application, it can leverage both ways, your data and the open data. Would you know if Copilot 365 internally uses a vector database? Um, Not that I'm aware of, and if they do, um, probably they're doing something much more kind of like complex, right? Because the thing with 365 is that you need to associate with Graph API and the whole kind of like ecosystem, right? So I think it's not just purely vector database. It's not something like you're storing all of your data, like all your Word documents, your images on OneDrive, they're stored in a vector database. Probably not. But I'm pretty sure they might be leveraging something like Graph API to be more efficient in terms of querying the right information for you. Harry asked, so the ML engineers create a private access backend service for use for yes, pretty much, right? So that means, again, just going back to that equation earlier, programmers can focus on populating the data, and the ML engineers can focus on creating their inference models, like creating the smartness of the applications. Okay, on the architecture diagram, this deep learning model means it can, just like what I told earlier, right? In that example, it can be something like an open AI GPT or like an LLM. So through vectors and embeddings, they can actually kind of like correlate to each other. Okay, so last one. Typically, it seems vector databases are exclusively used for RAG architectures coupled with an LLM FM. So if you actually look at the their positioning, actually, um, RAG is dead. Um, this is a very interesting question, right? Um, so there's a article by Qdrant officially that they mentioned that RAG is dead, but long live RAG, right? I think it's worth reading this context. Harry. But the idea here is that Quadrant is not just for RAG application. At least that's their positioning it, or any vector database of some sort, right? Like it's just so happened that that's where the trend is at the moment with RAGs and like LLMs, vectors, um, and embeddings. But the technology already existed back then when you're doing image search similarity, right? So besides RAG, you can do something like, geospatial, right? Let's say you want to create a digital twin of a building, then you can kind of like use vector database to associate, which floors have fault, which floors have, like if you taken a picture of a door, you can kind of like associate which door is it in that whole building, right? So that's just one example that you can actually kind of like compare it to. Okay, can you share the link of the article? Just search for "Rag is dead, long live Rag." It's gonna appear straight away.
I've
All
popped
right,
it in the chat as
all
well
right,
for you,
all good.
MJ.
All right, thanks for the interaction, Harry. Okay, so now when with Quadrant, there are a bunch of different hosting options out there in Azure, right? So the first option is to actually use cloud.quadrant.io. So Quadrant as a company again, like I think there are like three layers here, right? It gets confusing as well, like OpenAI, right? So Qdrant as a company, right? There's the company behind Qdrant, and then there's the open source Qdrant, you know, technology that we're talking about here, right? And then there's a Qdrant Cloud, which is kind of like the company behind this technology. They created a cloud-based option for you, right? Like, so let's say you wanna host Qdrant, besides hosting it locally, obviously. Like, let's say you wanna host it somewhere. Um, Using cloud.quadrant.io allows you to easily scale up, spin up a Qdrant instance, right? And it's all managed by the Qdrant company, right? So that means that if you choose something like Azure or other cloud providers, the one supporting that is still Qdrant, right? So the company behind is still the one maintaining that. Like it's kind of like becoming more like a SaaS model, right? But you can have an option where do you want to host it, right? In which Azure region, in which cloud you want to host it, right? The second option is that you can do something like Azure Container Instances. So for those who don't know Azure Container Instances, is that it's the easiest or simplest way to host any Docker container, right? So because Qdrant is an open source technology, and as part of that open source technology, you can actually pull the container image from Docker registry. So it's registered in Docker. So that means that you can use something like Azure Container Instances to just pull out that container image, right? I'll show you later on in the demo on how easy that is. Then the second option is Azure Container Apps, right? So Azure Container Apps, for those who don't know, is kind of like a managed Kubernetes. So, but without the whole drama of maintaining Kubernetes, right? So what that means is that it's not as simple as just running a single container instance like Azure Container Apps, but it's not as complex as running the whole AKS cluster or like Kubernetes cluster, right? Container apps allows you to focus on a bunch of like services. Let's say you have like 5 microservices, and then you wanna have a separate container for Quadrant and like another container for, let's say, your product service, another container for billing service and stuff like that. So container apps allows you to actually host those different containers for you and let them talk to each other, like assign different ports, create those different rules which are public facing, private facing, and stuff like that. um, but yeah, without the hassle of maintaining the whole Kubernetes cluster, right? And speaking of Kubernetes, obviously AKS is an option, right? So it's highly scalable if you want to go through that route. Like you can scale it to a bunch of different pods out there, and how you know up to how many instances you want it to be. Um, but then again, right, it requires more maintenance on your end, right? It just needs to be more operationalized on that end. But that also means that if you go to AKS route, there's more control on the infrastructure and the hosting capability that you're providing, right? And lastly, I just didn't put it in here, but there's a fifth option, which is hosting it in an Azure virtual machine, right? That's kind of like straightforward, but just mentioning that it's also an available option out there. Okay, so let's go to the demo for this one. All right. So now just going there. Let's see. Okay. There you go. So first I'll go to like the Quadrant Cloud. So to go there, you can go to cloud.quadrant.io. They offer free tiers out there. Unfortunately, they're on a different cloud at the moment, the free tier. But yeah, that's something to consider at the moment, right? But if you want to go through the Azure route, so you just have to go to clusters, go create, and then you have to go through the standard tier and choose a provider like Azure, right? And at the moment, it only supports 3 regions, which is Virginia, Europe, and Asia. And then from there, you just have to kind of like choose different options here and there, and just create that, and that's going to be billed to you on a monthly basis, right? Um, Again, this approach, if you go through this approach, it's all managed by Qdrant, like the company behind the technology, and this SLA is something you have to deal with them, right? So this is an SLA with the company, not with Azure, in particular, right? So yep, if you go back here, right? Let's say you wanna use this MJ free tier out there. So let's say you want to open the dashboard. So the good thing about Quadrant is that it comes with a dashboard that allows you to actually interact with it, and it's very user friendly, right? Now it's asking for an API key. All right. Now let me just pull that up. Okay. Um, Let me just pull that up. Okay, apply. Don't need to save that. Okay, no collection at the moment, right? So Quadrant comes with this kind of like console, right? In the dashboard, you have a console to do something like perform kind of like curl based or HTTP based type of operations, right? Let me just minimize that. Yes. So do something like if you try to perform this, like do a command enter or like control enter, right? Nothing is in here at the moment, right? But then if you go through something like tutorial, right? You can do something like a quick start. So um, this particular one creates a collection, right? So if you click and run that, so that creates that collection, which is test collection, right? So it's a put HTTP command that it's basically wrapped through this interface, right? So if you go now to collections, you would see that, hey, test collection was in there, right? But if you look here, nothing in here at the moment. You can see some info like config settings and stuff like that. Okay. Now let's go back to that tutorial. Okay. That quick start. Now let's add some vectors. So in this test collection, so it's basically a REST-based kind of like approach wherein like collection slash the collection name and the actual method that you're trying to interact with, and then again it's a put command, right? I'm particularly much more used to everything's like a post and a get, but in this case they are using put. Let me run that. So now if we go back to the collections and look there, now we have point one, point two, three, four, five, right? Six, so on and so forth. Like the payload as part of this is like city Berlin, city London, city Moscow, New York, Beijing, Mumbai, right? Now if you do something like go back to to the tutorial, let's do something like run a query wherein like which of the stored vectors are most similarly to the query vector, right? So try to run that. Okay. So now you can see that New York, again, right? You're not talking here about word search, right? It's not the word search that you're looking for the word New York, right? You're looking for the vector. If you recall, you're trying to perform a vector search, right? So what you're searching is like, hey, here's the vector that I want, or it could probably an embedded sentence or something. Now I want to search that through that database of vectors. And there you go. I was able to categorize that New York is much closer than Berlin. And you can also add filters here wherein like if you can mix and match vector search with a word search. So something like you can perform a filter city, a must London, right? So if you look at here, something like this, right? this is where it's a bit different from something like AI search, because in Qdrant they prefer to do, or like the approach is to perform a vector search first, prior to the like the word search, right? And then the word search, or like this other search, is in a form of a filter rather than a category of search, right? So again, that's just one thing that's a bit different with Qdrant compared to AI search. So that's pretty much it in terms of like, just a quick getting started of this one with Quadrant, right? Obviously, the power it a database can just be as straightforward and as complex as you want it to be. You can have as many collections out there. You can have perform more queries and stuff like that. But at the end of the day, what matters here is that this quadrant has a concept of a collection, and within that collection you have a bunch of points, and within that points you want to perform a search which point is the nearest, right? And that's the whole point. No pun intended. Now let's talk about hosting, right? Let's say you're happy with quadrant, I want to explore this, and like what are now let's run through those different kind of like hosting options out there, right? um, so to do that, let's first start with, if you go through something like if you want to go to something like local, it's as simple as just doing like performing a Docker pull of Quadrant, which is again the company Quadrant as the technology, right? So perform a Docker pull of Quadrant and Docker start. It just allows you to start this container image, right? So if you look at something like Quadrant in Docker, of course, yes. No, no, no. If you perform, there you go. Yeah. So in Docker Hub, right? So it's as simple as just performing a Docker pull and assigning a port, right? Um, in some cases, or for reasons, Quadrant decided to use the port 6333 as like their default port out there, right? So just be mindful of that. That 6333 is like the default port. um, yeah. So now that means that if you go through the route of local, all you gotta do is just go localhost, slash dashboard, yeah, and interact with it, right? Um, Same thing, same concept. You have collections, you have points, so on and so forth, right? The good thing about the Quadrant dashboard as well is like it supports image, search, image kind of like Explorer capability, and something just to be aware of. And if you want to test out Quadrant more, there's like a bunch of data sets in here that you can play around, like mid-journey styles, which you just saw earlier, and the documentation as well, wherein like they chunk the whole documentation and create embeddings, and like you can perform a search with that one. Now that's straightforward, right? Like let's say you wanna just run locally. So just again, Docker pull, Docker start. So and that's it, right? Now, if you wanna perform a Docker, sorry, if you wanna now perform Quadrant on Azure in particular, right? Besides the hosted option in Quadrant Cloud, now you again those three options I mentioned earlier. I'll just run through that now. Okay. So first is this ACI instance. Okay. So in ACI, so let me just go here. Okay. So what happened here is that I created an Azure. Let me just zoom in a little bit. All right. All right. So in ACI, all you gotta do is just create a container instances. And again, for those who don't know container instances, just go to the Azure portal and search for container instances, right? And just follow the whole wizard to create that. And from there, what's important is that here you want to assign a container. So you go to the containers in here, and in the beginning of that kind of like setup, it's gonna ask you which container you want to choose, and so on and so forth. And from there, you can see that it's just the public quadrant that I mentioned earlier. Um, so it literally just pulled that Docker image, but instead of running it locally, it's now running on Azure, right, through container instances. So that means that if you go through this route, so you just go to the overview and you can assign an FQDN, or you can reference the public IP address. So if you literally, copy the FQDN, fully qualified domain name, um, so now from there, you can do something like this one, right? So here, the suffix of a container instance is, the container name, the region, and the container Azure container.io, right? And as you can see, it because I just pulled the default image, it allows me to interact with 6333 as well. And if I go dashboard datasets, there you go, right? Now I'm in that same page as I was in cloud and the local host option, right? So there you go. Like yeah, see, they were able to reference Ragisted in the article. Um, okay, so that's very straightforward as well, right? Like the advantage of container instances is that because it's a long-running stateful instance, meaning that it's as if so if you literally stop this, the application stops, and if you start this and restart, like it follows that stateful movement of the data and compute instance, right? So that means if you're not using it anymore, you can just stop it, and it stops. But then you're not losing all your data in there, right? Like you're just stopping the actual machine that's running it. And then if you start again, the service comes back up, and you can access that data again, right? And the advantages as well with container instances is that you have managed identities you can assign here and there, so that you don't have to if you're doing some app service interaction to container instances, it's all managed for you without having to create a bunch of like keys or API keys of some sort. Right now, the second one, actually, before I go there, I'm seeing a lot of message from Harry, which I'm very fascinated to answer and try my best to answer some of them. All right, now let's probably start first with the looks like Quadrant cloud offering is similar to managed service offering. Yes, actually, you're right. Yes, it's very similar to like Confluent Cloud. That's correct. And Atlas with MongoDB. Yes, pretty much. And I think that by doing this, it supports the company as well, the company behind it, because you're technically paying them the surcharge of maintaining this for you, right? So it helps their business model. I think Azure Container Apps is a serverless Kubernetes offering. Yeah, well, pretty much Fargate and GKE. Yes, correct. And again, right, like just to point out with something like container apps, Fargate, and GKE, it really works well, especially if you're in that ecosystem already. Like, let's say you want to connect to these services, connect to that services. It really just makes sense to kind of like use this managed serverless Kubernetes. Okay, so okay, he pointed out they probably use HTTP put because it is idempotent. Okay, yep, that's a good point. Um, yes, Yes, that's actually a good point, meaning that if you put in the same data over and over, it just keeps on updating. Yes. Are there concepts like indexing or tuning with Quadrant as a data set? Um, Actually, that's a good point. I don't think there is, right? Because the idea is, again, with HSNW, is that regardless how, because it's a different data structure, right? It's not a table structure of, this type of kind of like to visually look at it, right? Like with SQL tables, it always goes like this, going down, 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 and like goes on and so forth. But with something like vector database, it's kind of like expanding, right? So it doesn't really matter how big the data is. It's just about how close you are to each other. So I think, um, yeah, I think it's a different technique, right? Like, I think it will come into filtering capability to improve the accuracy, right? Because it's not a question of can I find it or not. It you can find it, right? It's just a question of is it relevant for you, right? What you find. So I think it's more of like a filtering or like searching problem rather than kind of like an indexing um, problem. So is Quadrant optimized for read write like a relational DB? That's a good point, right? So my approach with this one is that because if you look at databases, right, and like data stores in general, it's if you treat it as ACID based, when I say ACID, like a SQL based type of capability, you would look at it that hey, it might have a read write um, limitation, but if you actually look at it from the diagram earlier as well, right, the interface to actually insert versus the search doesn't interact with each other, right? So that means that they're separate capabilities on their own. That's why Quadrant is well positioned saying that, hey, we're not a search database, right? They are kind of like a vector technology. So um, I think, yeah, like, yeah, I think it's a matter of because when I tried it, right, with the actual work that I do, right, with billions of rows, I didn't feel the challenge of scaling, right? Like it didn't felt like I had to index this and that. So that's why I just didn't feel the need to think about it more often. So how do you purge obsolete data? Okay. Yeah, that's actually a good point, right? So within Quadrant, so obviously you can do this via API, but in collections you can also do something like deletes, right? But you have a concept of snapshots in Quadrant, wherein like if you go through the SQL days, you have backpacks, stuff like that. But in this case, you can actually kind of like you can archive a collection and kind of like create a point in time version of that one as a form of snapshot, right? And then you can kind of like recall that later on and upload it back again. Um, okay, so okay, what kind of authentication does Quadrant support? So at the moment, right, the support for Quadrant, like if you look at it, like let's say Quadrant Cloud, right? It's guarded by an API key. Okay, so that's why if you go to this option, it's all just API key based, right? And that's it. Now, if you go to the territory of Azure, there are a lot of different ways you can guardrail this, right? And that's where you can do something like Entra, AAD, OAuth, or you can do system manage, user manage, and so on and so forth. And again, as you go through the route of you want to go the full AKS or container apps, a lot of different options are up for you. Um, okay, so I think for the question, can you control access to various parts of the quadrant schema? Um, I think that's where something like if I prefer for you to go to the Azure territory for that one. You have more advantage of like maintaining those set of keys, right? Like let's say going back to the ACI, like if you go to identity here, you have more support in here, right? Like all the user assigned and system assigned identities you can manage here. However, if you go through the cloud quadrant at the moment, it's all just that API key. Don't ever share that API key. But I think there are like a bunch of different access management capabilities out here that you can add them more of like owner, admin, but it's not to that fine grained details of access, right? Um, sorry. So, okay, I'll just close up with you, Harry, with the last question of going back to your answer performance. It sounds like graph database when you follow connection. Yes, pretty much, right? Like, so actually, Yes and no. Okay. Let's just go. The easiest way to explain it is to actually just go to quadrant.tech. So like if you go to this documentation, right? And um, like what is quadrant? So this is what I was talking about earlier, right? So an OLTP database is something like this, and an OLAP is something like this, and vector is something like it expands like this. This vector is something that expands um, vertically, but the payload expands horizontally, right? So um, it's kind of like yeah, like a matrix type of setup wherein it's about how near you are in that space. There's another diagram I had in the previous slide, in the previous talk, that I kind of like explained like how it's a bit different. Okay, so last one, what APIs? Actually, Quadrant supports gRPC and REST API at the moment. Yes, that's correct. All right, now let's go to the container apps route. So if you want to go through container apps, so go back again, go to Azure portal and just create, search for container apps. And from there, the hierarchy of container apps is that first you need to create a container apps environment, and then within the environment, you create container apps, right? So if I go through my resource group here, right? So what I have is this container apps environment, Reactor quadrant that I created there. That's a container apps environment, and within there, I created two container apps in here. We're in like a quadrant um, that is via a gRPC, and a quadrant via HTTP, right? Again, um, that's something you can kind of like mix and match. We're in like if you go back here, let me just quickly explain container apps, right? So again, container apps environment is, think of it like your managed serverless Kubernetes, right? And within there, you can set up, certificates. You can mount drives using Azure files, set up, DNS and stuff like that, right? And logging capabilities here. Now, within this managed Kubernetes environment, you have apps, right? And within apps, you can create, either an app that's, you can interact with, or a job. So a job is more like a cron, like like a scheduled type of activity that's mostly not, interactable via the user or system. Um, so when you create an app, basically, let's say this HTTP in here. So within here, that container app now contain the containers, right? Again, you can point which container that container app hosts, right? And then you can perform revisions here and there, depending on, let's say you point it to something like an ACR or Azure Container Registry, you can point a bunch of different revisions in there. That means that if you, let's say, there's a new version of Quadrant, you can always kind of like revise that, right? Um, the thing here, if for those who are familiar with Kubernetes, you have this set of environment variables, health probes, and stuff. Like these are all like managed for you, instead of actually kind of like interacting with them. And here's the scale part. We're in like, let's say you can have an HTTP scaler in here to allow you to kind of like create some rules. Um, yeah, and like kind of like yeah, then from here, we can look at something like gRPC as well. And if you look at the scaling capability in here, you can actually scale it by a TCP as well. So that's the beauty of using container apps, is that unlike container instances doesn't support gRPC yet at the moment, or HTTP/2 in particular. But if you go through the container apps, you have that option ready for you. So that means that using gRPC is an available option for you straight away, right? Um, Okay. Now, okay, so there are a bunch of different configurations here as well that you can choose at with Azure Container Apps, such as, again, managed identity, cores, resiliency, and so on and so forth, right? But the most important part for me really is the ingress. So that means that with ingress, you can kind of like define without, interacting with the whole Kubernetes CLI and API and kubelets and stuff. You can just interact them using a bunch of clicks. Um, like, hey, you want to ingress enabled, meaning, you want it to be interactable. So yes, but you can say that you only limited to container apps environment, meaning only those within this managed Kubernetes can talk to each other, right? Or you can do something like accept traffic from everywhere, right? And then you can choose the ingress type, which is like which protocol to use. So HTTP for REST base and TCP for gRPC, right? And like you can set the target port in here, and then it creates an endpoint for you, right? And these endpoints are obviously, they're this is the first one is the internal endpoint, right? And then the second one is like the external endpoint, right? And then you can have some traffic rules in here wherein like, you can allow to all traffics or like allow deny like certain, range or something, right? And obviously you can set up custom domains as well if you want to kind of like do that. So in action, it's the same thing. So if we go here through the, let's probably better idea to use the HTTP one. So if you go to the application URL, just go there, and then I think 6333 slash dashboard. I think I have it in here. There you go. No, okay, so no need for the 6333 because yeah, I do remember I binded it to the HTTP, which is 443 for HTTPS. So no need for that one. Um, But there you go, right? Like same thing. You can host Qdrant on Azure Container Apps, right? You can perform that same tutorial that we just went into earlier. Yeah, task collection and so on and so forth. Like, if you try to get the collection name, uh, okay, obviously collection name doesn't exist. I think it's called text collection, right? Something like that. So it gets the collection info by a curl, and then you can do something like this. Um, There you go. Okay, I think that's all the time I have. Then let me just go back to my slide. I wanted to show the AKS, but it's just again much more complex config settings out there. But it's the same idea, right? Running the container within that Kubernetes environment. Okay, now let me just go from my current slide. So if you want to learn more, there are a bunch of resources out there. Again, Qdrant.tech is their main website. Um, there are a bunch of Azure samples out there that you can actually use already. Like if you just go to Azure samples Qdrant/Azure. Um, and for those .NET developers out there, listening in Reactor, Qdrant actually have the .NET client as well. Um, However, that .NET client is currently gRPC only at the moment. So there is the guy AliExpress RU who created the uh, web API or the API based kind of like wrapper for you as well. So with that, thank you very much, and you can reach me out through this contact or just add me on LinkedIn in there. Um, I still have around 5 minutes. I can try to answer some of the questions. Yes, Harry, I'm available in LinkedIn. Yes, add me in there. Um, okay, so wow, Harry, so much to rap about from you. Okay, I'll probably just go through scaling quadrant. Okay, I think scaling quadrant in particular, right? I think again, if you go through that quadrant cloud model, right? So if you look at clusters, there are different ways you can take a look at it, right? You can actually scale it in a way of how much RAM disk you want for this, right? But again, take note that one vector or one point is just very small data, right? Like it's not big data out there, right? Um, so that's why scaling this could mean vertically bumping up this cluster, this in Quadrant Cloud for you, right? Now, the second part of the equation of scaling is that if you want to create a multi instance of Quadrant, right? And I prefer to do that on Azure than in Quadrant Cloud, wherein like, I don't want to do something like point to API 1 with API key versus API 2 with API key. Um, and that's where something like container apps and AKS would really be handy, right? Because you have a lot of controls within, the scale, the revisions, the replicas, the scale that you want it to be. Like you want 300 instances or 200 or something. You have that option, right? But here's the challenge there, right? If you scale a data storage like Quadrant, now you have to deal with that kind of like situation we're in. Okay, on replica one, um, I have this data over here, and on the replica two, I have the other data over there, right? Now the separate problem statement that you have to deal with, right? And that's where it's worth considering that are you really doing a vector-based solution or something like a database or a NoSQL like Cosmos type of approach is the best way forward, right? Then again, right, it varies on application, but so far, again, with billions of rows, I was able to use container apps with one replica only. Didn't cause a lot of problem for me, right? So with that, thank you very much. And I think I'll see you next time on the next topic wherein I'll be talking about Postgres and still within vectors, right? But I'm gonna talk about Postgres, which is the most loved database, open source database out there.
Yes, and it'll be on the 16th of April, and I have popped the meetup link in the chat as well for you to go and register, and you'll be able to catch the recording of today's session on our Reactor YouTube channel as well. So I want to say a massive thank you to MJ, and thank you so much, Harry, and to the rest who put their questions in today. We look forward to seeing you all again soon. So bye for
All
now.
right. Bye. Thank you.